What's up, everybody? I hope you are all doing well. Today, I want to do some coding and watch some videos about machine learning so we can watch them together and learn some new stuff. Today, machine learning is very important. If you don't know it, they don't give a fuck. They don't care if your knowledge is useful or no. It's a necessity, everybody should know. So let's go learn coding, learn machine learning, and that will be amazing. Alright, I want to start with machine learning because we should just watch some videos from YouTube. I'm watching Andrew Ng or Andrew Ng machine learning course on YouTube from Stanford. I don't take the course very seriously. I just want to get to know the basics. It was not machine learning was not my focus in my research, so I didn't care about it much. But then I was applying to internship and everything, and there. So they said, without machine learning, without coding, fuck your data market. I said, fuck you guys. Do you think I will stop my data market? No, I will adapt. I will change my strategy. Now I want to get closer to machine learning. Maybe a lot of you know already, and so that's good. Okay. Where is machine learning? It's here. You should make these noises. It's like car starts to work. At the beginning it's difficult. Builds your momentum and you will make it finally. So, let me see. Fucking Thanksgiving was fun, but my work is fucked up. Alright, everything good. That's it. We are 1 hour inside lecture 5. They are talking about GDA, which is Gaussian discriminative. A. What does A stand for? Stanford. GDA, machine learning, Gaussian discriminant analysis, and then naive Bayes. Actually, I was watching this stuff, like a lot of them I know, but I just didn't learn them in the literature of machine learning. There are Bayesian inference, there are like computing Bayesian, what is it? Jointly Gaussian, multiple Gaussian distribution. These are about this stuff. They're not like crazy shit. Oh, machine learning. What is that shit? Oh. No, yeah, they're just regression. Just draw a line that separates two pair of points. It's just easy shit, man. You see the line. There, that's there. Draw the line. Who cares if the lines are a bit this or that? Nothing very special so far, to be honest. Damn. Cold water. Cold water. Amazing. Amazing, especially when you have machine learning. Guys, go grab some cold water. Pull out your Andrew NG playlist and let's watch. So. Let me turn it up.
Both logistic regression and Gaussian discriminant analysis actually end up using a sigmoid function to calculate your P of y equals 1 given x.
You can hear it or no?
The outcome ends up being a sigmoid function because the mechanics is you actually use this calculation.
I should add something that we have my screen and you have me. I'm thinking about it, guys. That would be better.
When I was projecting the results on the display just now in PowerPoint, that the two algorithms actually come up with two different decision boundaries. So let's discuss when a generative algorithm like GDA is superior and when a descriptive algorithm like logistic regression is superior. Let's see.
Guys, my hamstrings. I have to do stretch. Fuck, I didn't do for a long time. My quads are killing me. And I have leg day tonight. Oh my god. Guys, take stretches serious because the whole week you are tired. Do 15 minutes of stretch and then you're good to go. This is stupid. I think the benefits are much more. And it is easy. Don't make excuse. Don't make any excuse because you can do a stretch here. Like you're sitting here, this guy's talking. Do some stretch. It's not a very time consuming or focus consuming. 30 seconds does miracle.
Strange wind at the back, is it? Okay, cool. Alright. Yeah. Boy.
Something happened in the class. I think it's an alarm. And they're laughing, they're having fun, watching machine learning. Bing, 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 bing. Students are having fun because the teacher cannot teach anymore. Did you see that, dude? Teacher said, hurricane stopped. Everybody was laughing. Just that. Oh, I think hurricane stopped. And every full class of people, like Stanford people, geniuses, were laughing at hurricane was stopped.
Let's see. So what logistic regression assumes is P of y equals 1 given x. That this is governed by a logistic function, right? So this will be 1 over 1 plus this negative thing in transpose sense. With some details about x0 equals 1 and so on, right? So just okay. So in other words, let's assume that this is P of.
I should not look at these emails I receive. Sorry, you have to practice.
Just described just now.
Fuck you. Distractions. Assholes.
On the other board. What that illustrates, it doesn't prove it. You prove it yourself in a homework problem what it illustrates is that
Doesn't know how to prove it, tells people to do it in home.
implies that P of y equals 1 given x is governed by logistic.
I will do my stretches.
But it turns out that the implication in the opposite direction is not true. So if you assume P of y equals 1 given x is governed by the logistic function, by this shape, this does not in any way, shape, or form assume that x given y is Gaussian, x given y equals 0 is Gaussian equals x. So what this means is that GDA, the generative learning algorithm in this case, this makes a stronger set of assumptions.
I don't know even if doing a stretch is good before your leg day.
Makes a
You should do stretch after your workout, but my legs are so sore.
weaker set of assumptions because you could prove these assumptions.
I did
from
chest
these assumptions.
yesterday, so maybe I should do chest to stretch.
And by the way, as a
Wait. Guys, it's 3 weeks. I'm stuck with doing 5 reps and 205 pounds for bench press. And I don't really know, fuck! I don't know how to. I want to do 6 reps and then move up the weight. But I'm stuck here. If you have any suggestions, please let me know in the comment how to make my 5 reps 6 reps. Alright.
let's see. And so what you see in a lot of learning algorithms is that if you make stronger modeling assumptions, and if your modeling assumptions are roughly correct, then your model will do better because you're telling more information to the algorithm. So if indeed x given y is Gaussian, then GDA will do better because you're telling the algorithm x given y is Gaussian, and so it can be more efficient. And so even if you have a very small data set, if these assumptions are roughly correct, then GDA will do better. And the problem with GDA is if these assumptions turn out to be wrong. So if x given y is not at all Gaussian, then this might
Do you see what he said? In real life, our assumptions do not work. It doesn't matter. If it is true, it's better, but.
So here's one fun fact. Here's another example, which is let's say the following are true. Let's say that x given y equals 1 is Poisson with parameter lambda, and x given y equals 0 is Poisson with mean lambda 0, or lambda 1, lambda 0, and y as before is Bernoulli phi. Right? It turns out that this set of assumptions also imply that P of y equals 1 given x. It's logistic. Okay, and you can prove this.
What does logistic?
Any generalized linear model.
Oh, it is 1 over e plus.
Where
Alright.
the difference between these two distributions varies only according to the natural parameter.
And we know Poisson and Gaussian are.
And so what this means is that if you don't know
Tell me,
the data,
what are they?
it's Gaussian or Poisson.
Exponential family?
If you're using logistic regression,
Is
you
it
need
true
to-
every exponential family ends up in logistic?
So maybe you are fitting data to maybe fitting a model, primary classification model to some data, and you don't know, is the data Gaussian, is it Poisson, is it some other exponential family model? Maybe you just don't know. But if you're fitting logistic regression, it'll do fine under all of those scenarios. But if your data was actually Poisson, but you assumed it was Gaussian, then your model might do quite poorly. So the key.
That's a good thing.
We
It talks about real life. It says if you're real, we can have like a theoretical assumption, right? You assume Gaussian, but your data is Poisson. It says no, you're fucked up. The results will be poor.
If you make weaker assumptions, as in logistic regression, then your algorithm will be more robust to modeling assumptions, such as accidents you assume the data is Gaussian. It's not.
Dude, this is my hamster.
But on the flip side, if you have a very small data set, then
Hamstring is
a
fucked.
model that makes more assumptions will actually allow you to do better, because by making more assumptions, you're just telling the algorithm more truth about the world, which is, hey algorithm, the world is Gaussian, and if it is Gaussian, then it will actually do better.
Yes, of course. But if it is wrong,
A few questions. Good.
this dude,
Oh,
this fucking student, I don't know who he is. His voice is like, I don't know if it is the class environment, the microphone setting, but his voice like everyone, every time he asks question.
Yeah, practice that moment of data is a Gaussian property. It's it's a matter of degree, right? Most data on this universe is Gaussian.
Most data on this universe are
Except the speed
Gaussian.
yes, yeah. But so I think it's actually a matter of degree. Right? If you plot, actually, you take continuous value data. There are exceptions. You can plot it, and most data that you plot, will not really be Gaussian, but a lot of it you can convince yourself is vaguely Gaussian. So I actually tell you the way I choose to use these two algorithms. So I think that the whole world has moved toward using bigger and bigger data sets, right? Digitalized society, which is a lot of data. And so for a lot of problems, we have a lot of data.
With only problems, we got a lot of data.
Because with more data, you could overcome telling the algorithm less about the world, right? So the algorithm has two sources of knowledge. One source of knowledge is what did you tell it, what the assumptions you told it to make.
And what the real data you gave them.
The data. And in this era of big data, with a lot of data, there is a strong trend to use logistic regression, which makes less assumptions and just lets the algorithm figure out whether it wants to figure out from the data. Now,
So,
for practical reason,
less assumptions, giving the raw data to the algorithm, and it will figure it out.
I still use algorithms like GDA, general discriminant analysis, or algorithms like this, is that it's actually quite computationally efficient. And so there's actually one use case at Landing AI that I'm working on where we just need to fit a ton of models and don't have the patience to run logistic regression. And it turns out computing mean and variances of covariance matrices is efficient. And so there's actually, apart from the assumptions type of benefit, which is a general philosophical point, we'll see again later in this course. Right? This
Philosophical
point.
point.
This is a general principle of machine learning that we'll see again in other places. But concrete, the other reason I tend to use GDA these days is less that I think of the form better from an accuracy point of view, but it's actually very efficient. Just computing covariance and you're done. There's no iterative process needed. So these days,
Oh
I
my
use these
god.
models,
It's gonna kill me.
motivated by computation and less by performance. But this general principle.
You know what would be good? Andrew and G, we had them, and like Pamela Rife and Andrew and G were teaching together, and I was like learning machine learning and doing my stretches together. That would be amazing. Like now watching this, my mind is all Pamela Rife.
Oh, right. So what happens to the covariance matrices?
I haven't done caps for 2 weeks.
It still
But I still do the stretch.
A bunch of quadratic terms in the logistic function, so it's not a linear digit boundary. You can end up with a digit boundary, that looks like this, right? A positive negative example separated by some other shape. You could fix actually. If you're curious, I encourage you to fire up Python NumPy and play around with parameters and plot this for yourself. Yeah, this is we did some statistical tests to see if it's Gaussian. I can tell you what's done in practice. I think in practice, if you have enough data to do a statistical test and gain conviction, you probably have enough data to just use logistic regression. I don't know. Well, no, that's not really fair. I don't know. If a very high dimensional
What
data,
happened?
I think Gaussian. can tell you what's done in practice. I think in practice, if you have enough data to do a statistical test and gain conviction, you probably have enough data to just use logistic regression. I don't know. Well, no, that's not really fair. I don't know. If you have very high dimensional data, I think what often happens more is people just plot the data.
I didn't get why they left, honestly.
If it looks
It was good. It was good. I think it was like there's no point in GDA, but I didn't get like I cannot hear this guy.
on Gaussian, then that would be reason to not use it.
Yeah, I think it's just
What happens
said what happens in real life. Said GDA doesn't work. They came to the conclusion.
Sometimes you just have a very small
Conclusion.
data set, and it's just a matter of judgment, right? Like if
It's
you
a
have-
matter
if
of
you have,
judgment.
50 examples of healthcare records, then you just have to ask some doctors and ask, well, do you think the distribution is relatively Gaussian, and you still don't understand that. Right? I think, by the way, another philosophical point, I think that the machine learning world has, frankly, a little bit overhyped big data, right? And yes, it's true that when you have more data, it's great, and I love data, and having more data pretty much never hurts, and usually the more data, the better. So all that is true. And I think we did a good job telling people that high-level message. More data almost always helps. But
In general, more data is better.
I think a lot of the skill in machine learning these days is getting your algorithms to work even when you don't have a million examples, even don't have 100 million examples. So there are lots of machine learning applications.
There are a lot of machine learning algorithms. We don't have a lot of data, but still we want our algorithm to work. So don't think you are sitting at your home and say, oh, I have a lot of data, it does whatever I want. No, it's not the case. This guy is a professor at Stanford. He says, sometimes we don't have a lot of data. You have to come up with solutions. You need to use your fucking brain.
Where you just don't have a million examples, you have 100 examples. And
100 example is nothing. In machine learning, 100 example is nothing.
Take something like ImageNet, million images. There are now dozens of teams, maybe hundreds of teams, I don't know. They can get great results if you have a million examples, right? And so the performance difference between teams, there are now dozens of teams that get great performance.
What is teams?
For image classification, like ImageNet. But if you have only 100 examples, then the high skill teams will actually do much better than the low skill teams. Because the performance gap is smaller. So, and I think that is these types of intuitions, what assumptions you use, generative, descriptive, that actually distinguishes the high skill teams and the less experienced teams and drives all the performance differences.
The weather is.
Oh, and if someone goes to you and says, oh, you only have 100 examples, you never do anything, then I don't know, if there's a competitor saying that, then I'll say, great, don't do it because I can make it work. Well, I don't know. But I think there are a lot of applications where your skill in designing a machine learning system really makes a bigger difference. It makes a difference from big data and small data, but this is very clear when you don't have much data. It's the assumptions you code into the algorithm, like is a Gaussian, is a Poisson, that skill allows you to drive much bigger performance than a lower skill team. All right, let's just take questions from all group. Yeah, go ahead.
I thought Tisha was winking.
Oh, sure. So does this, so what's the general statement of this? Yes. So if x given y equals 1 comes from an exponential family distribution, x given y equals 0 comes from an exponential family distribution, the same exponential family distribution, and if they vary,
I told it, I fucking knew it.
Then this would be logistic.
If it is exponential family, guys, this exponential family thing, don't take it so simple. It's crazy.
One last question.
It works so nice.
Does performance improvement or even as you increase number of processes? I think so, yes. And the generalization of this would be the softmax regression.
I have to go pee.
Yes, I think the similar thing holds true for GDA for multiple. And we have so far we're going to talk about binary classification, whether you have more than 2 classes. But yes, similar things holds true for like GDA with 3 classes and softmax. Oh yes, right. You saw some activity. Cool.
Cool.
And this theme that when you have less data, the algorithm needs to rely more on assumptions you coded. This is a recurring theme that we'll come back to as well. This is one of the important principles of machine learning, that when you have less data, your skill at coding in your knowledge matters much more. This is a theme we'll come back to.
What is this? You put your Instagram on the public mode, and every fucking bot starts following you. Alright, blocked.
When we talk about much more cognitive learning algorithms.
Okay, I have to go. I will come back. Stay safe. How are you? I feel relieved. Shit was heavy. How long did it took? 38 minutes. Alright. Alright.
I'm gonna fresh walk things.
Tonight I will use shampoo for finally.
So you've seen GDA in the context of continuous valued features X. The last thing I want to do today is talk about one more generative learning algorithm called naive Bayes.
Naive Bayes.
And I'm gonna use as a most main example email spam classification. But this I guess is our first foray into natural language processing. Right? But given a piece of text, like given a piece of email, can you classify this as spam or not spam? Or other examples. Actually, several years ago, eBay used to have a problem of if someone's trying to sell something and you write a text description. Right?
Like a subject of an email, basically.
Trying to sell it on eBay. How do you take that text that someone wrote in the description and categorize it? Is it an electronics thing? Or are they trying to sell a TV? Are they trying to sell clothing? But these examples of text classification problems. We have a piece of text and you want to classify it into one of two categories for spam or non-spam, or one of maybe thousands of categories.
This is a moment. Did you see that? Did you see that? It's completely muscle memory. I had nothing to do with the phone. Very swiftly, my hand went into my pocket, pulled it out, my thumb went up, opened it, and I was about to get distracted.
So the first question.
That's not me getting distracted. That's him being boring.
Is,
why don't you dance and teach us?
Problem. Given email classification problem, how do you represent it as a feature vector? And so in naive Bayes, what we're going to do is take your email, take a piece of email,
take a piece of email
to a feature vector X.
Okay, I have to get focused.
Which is first,
feature vector X.
Let's start with the English dictionary and make a list of all the words in the English dictionary. Right, so first word in the English dictionary is A, second word in the English dictionary is aardvark.
Wait, what? Second word in English dictionary is aardvark.
Wolf.
Aardwolf? What?
Seriously, look it up. And then,
now it's
email
legit.
stamp, a lot of people ask you to buy stuff, so you would buy.
Merriam-Webster.
And then the last word
A.
is Sigrid, which is the technological
It
chemistry.
is not true.
To the fermentation process in brewing. So again, this is a useful way.
Oh, aardvark.
Practice what you do.
We have it. Aardvark, a large burrowing nocturnal mammal of sub-Saharan Africa that has a long snout, extensible tongue. Oh, it's like a mouse. Aardvark. See, when he says something funny, it's also distracting because it's not about the course.
You look at the dictionary, but look at the top 10,000 words. It's easier to think about it as if it was a dictionary, but in practice, the other thing that's dictionary has too many words. But the other way to do it is to look through your own email corpus and just find the top 10,000 recurring words and use that as a feature set. So, right, in your emails, I guess you get a bunch of email from us and the others about CS229. So CS229 might appear in your dictionary. You're building an email spam filter for yourself, even if it doesn't appear in the official, was it like the Oxford dictionary? Just yet, just you wait. We'll get CS229 this. All right.
Oxford Dictionary.
And so, given an email, what we would like to do is then take this piece of text and represent it as feature vector. And so one way to do this is you can create a binary feature vector that puts a 1 if the word appears in an email and puts a 0 if it doesn't. Right? So if you get an email,
Okay, again, 0,
it
1.
asks you to buy some stuff, and then the word A appears in email, put a 1 there. They're not trying to sell odd wool, so 0 there. Buy, and so on. Right? So you take an email and turn it into a binary feature vector. And so here, the feature vector is 0, 1 to the n, because it's an n-dimensional binary feature vector, where for the purpose of illustration, let's say n is 10,000, because you're using, take the top 10,000 words that appear in your email training set as the dictionary.
I don't want to focus, actually, I don't want to focus that much. I want to just let it go. Even though I won't play 2x, I feel 2x is, I used to play 2x when I was younger. What is the point of it?
In other words, xi
learning fast. It's like we don't have time to learn. We have a lot of time, man.
appears in the email. Right? So it's either 0 or 1, depending on whether or not that word I, this list, appears in you. Now, in the naive Bayes algorithm, we're going to build a generative learning algorithm. And so we want to model P of x given y, as well as P of y. Okay. But there are 2 to the 10,000.
2 to the 10,000
possible values of x, right? Because x is a binary vector that's 10,000 dimensional. So if we try to model P of x in the straightforward way as a multinomial distribution over 2 to the 10,000 possible outcomes, then you need 2 to the 10,000 parameters.
I draw Gmail,
which is a lot. Well, actually, technically, you need 2 to the 10,000 minus 1 parameters because they add to 1, so you save 1 parameter.
2 to the 10,000.
So modeling this without additional assumptions won't work, right? Because it's excessive number of parameters. So in the naive Bayes algorithm, we're going to assume that the xi's are conditionally independent.
What does it mean? Conditionally. Okay.
Given y. Okay. Let me just write out what this means. So P of x.
If they're conditionally independent, are they independent as well?
Given y, by the chain rule of probability, this is equal to P of x1 given y times P of x2.
I don't think so.
X1 and y times P of x3 given x1, x2, y up to
fuck you, phone, get out.
So I haven't made any assumptions yet. This is just a true.
I just want to show up and watch.
By the chain rule.
I don't want to get involved in the course.
And what we're going to assume, which is what this assumption is.
That's actually how you will be in a class, right? You will be bored. That's it. And the content is not really related to me. I don't feel it. So, okay, I have to be more focused, guys, because I have to apply for internships. We need this fucking thing. But I don't feel it right away, so my sensors are not active.
This assumption is also sometimes called the naive Bayes assumption. But you're assuming that so long as you know y, the chance of seeing the word Bach in your email does not depend on whether the word A appears in your email. And this is one of those assumptions. It's actually not a true assumption. It's just not a mathematically true assumption. Just that sometimes your data isn't perfectly Gaussian. You see this Gaussian, you can kind of get away with it. So this assumption is not true in a mathematical sense, but it may be not so horrible that you can't get away with it. And so, side, if any of you are familiar with probabilistic graph,
it can be like a brand
28. This assumption
Logo
is summarized in this picture.
looks good.
And if you haven't taken CST 28, this picture won't make sense, but don't worry about it. Right, that once you know the clause label, is it spam or not spam, whether or not each word appears or does not appear is independent. Okay, so this is called conditional. So the mechanics of this assumption is really just captured by this equation. And we just use this equation, that's all you need to derive naive Bayes. But the intuition is that if I tell you that this piece of email is spam, then whether the word buy appears in it doesn't affect your beliefs, or whether the word mortgage or discount or whatever spammy words appear. So just to summarize, this is product from I equals 1
So
and
mix
P of X I given Y.
Listen. So what is that? That's a very beautiful color, by the way.
All right. So the parameters of this model are, I'm going to write phi subscript j given y equals 1 as the probability that xj equals 1 given y equals 1. Phi subscript j y equals 0. And then phi. And just to distinguish all these phi's from each other, we're going to just call this phi subscript y. Okay. So this parameter says if it's spam email, if y equals 1 is spam, y equals 0 is non-spam. If it's spam email, what's the chance of word J appearing?
What's the chance of?
If it's not spam email, what's the chance of word J appearing in the email?
If it's not spam, what's the chance of the word J appearing in it? So xj is the word J, y1 is not a spam, y1 is spam, y0 is not a spam. Alright. That's it. Cute.
And then also, what's the clause prior? What's the prior probability that the next email you receive in your inbox is spam? And so, to fit the parameters of this model, you would, similar to Gaussian discriminant analysis, write out the joint likelihood. So the joint likelihood of these parameters is the product given these parameters. Similar to what we had for Gaussian discriminant analysis.
Gaussian discriminant.
Maximum likelihood estimates. If you take this, take logs, take derivatives, set derivatives to 0, solve for the values in
I
maximum.
feel it's the time to go have my
Find that
dinner.
maximum likelihood estimates of the parameters are phi
I don't want to have my dinner after
what you
gym.
expect.
He's writing down a lot of mathematical terms. We don't need them. Oh, MLE stands for maximum likelihood estimate. Oh, okay, it's a empirical mean, right? How many times we had spam? Oh, we have another thing parameter that says how many times we had a spam and the word J appeared over the total number of times that we had the word J. Yeah. Oh no, why? What the fuck? He's counting over all the times that we had spams. So we are computing the probability that if something is a spam, what are the odds that the word J is in it?
So that's the indicator function notation.
I guess
right?
that's it. That's it.
Look through your training set, find all the spam emails, and of all the spam emails, i.e. examples of y equals 1, count out what fraction of them had word J in it. Right? So your estimate of the chance of word J appearing.
Chance of the word J in it.
Chance of the word by appearing in spam.
By appearing in it.
All the spam emails.
Of all the spam emails in it.
Contain the word by. Fraction of them had xj equals 1. You'll see the word by.
Okay.
So it turns out that if you implement this algorithm, it will nearly work, I guess. But this is naive Bayes for email spam classification. And I'll mention the one reason this, and it turns out that
Again, back to Instagram.
Algorithm, which we'll talk about.
Dude, David Blaine is rocking it on Instagram. What's up with him? He was not there. I think he has a show or something. The only place I want to be on New Year's Eve is with David Blaine. Something happening about him. He's promoting. He's crazy, by the way.
This is actually
David Blaine, if you want to come and read a paper together, let me know.
actually a not too horrible spam classifier. It turns out
No joke, man. Here's PhD serious shit. Stop playing with cards and show up like a scientist.
Probabilities is just multiplying a bunch of numbers, so there's nothing iterative about this. It's going to fit this model very efficiently, and also keep on updating this model even as you get new data, even as you get new users his marker spam or whatever. Even as you get new data, you can update this model very efficiently. But it turns out that actually the biggest problem with this algorithm is what happens if this is zero or this, if you get zeros in some of these equations.
Mm-hmm.
We'll come back to that.
Well, if it is zero, nothing happens. If it is zero, nothing happens, right? We have no spam. We should be happy for it.
Learn about generative learning algorithms. We'll come back on Wednesday and learn about some more fine details how to make this work even better. So that's great. We'll see you on Wednesday.
Alright, I've done. Guys, thank you for staying with me. We watched 30 minutes machine learning. Perfect. How many courses? 20. 25% of the course already watched. Let's celebrate! Alright. Next stop is coding with Python 3. Alright. Recompile. What do you think about Andrew? I think he's a good teacher. He's cool. He's one of those professors that you like going to his class. Anyways, goodbye for now.